Right. You mean the actual name of the chapter? Writing it down now. So it is products, factors, and compound fractions. So just remember to do absentees. Okay, now I know that we spoke about factorizing mostly yesterday, but remember the first section of that worksheet was on product. And I know that some of you are a bit unsure about how to, if you have like something and then minus and then two brackets, how to sort that out. So yeah, sorry that we now have to go back and forth, but we are going to spend some time on product still today. All right, in AP, you need to be able to do more complex products than in core. All right, so I do want you guys to practice on those. So the kind of thing that I'm talking about is, I'm going to get to an example here. If we have like, okay, let's write that complex products. So that's something you haven't seen before, right? It's not that much, or it's not very different from what you've seen before, but you've never actually done trinomial multiplied by another trinomial, right? You've done binomial and trinomial, but not trinomial and trinomial. Okay, now there are two ways in which you could approach this, right? The first way is just quite straightforward, where you take each term in the first bracket, now there are three of them, and you multiply each term there by each term in the second bracket. So how many products are you then actually going to do? You're going to take A and multiply it by A and negative B and negative 2. And then B by all three, and then 2C by all three. So how many terms do we expect to get? 9, right? And then if there are any common, or sorry, not common, if there are any like terms from these, you will have to add or subtract those. Do that on your own, please. Yes. All right. Guys, we go. Okay, I have the answer up there, so you can just check that that is what you got. The order of those terms doesn't matter. You could have written them in a different order as long as all four of them are there. And obviously, you need to make sure that all the negative terms are negative, and then a squared was the only positive term. So if your a squared is somewhere else, it needs to be plus a squared. And say your negative b squared was first, must be negative b squared. Yes. I think if the minus no, it's perfectly fine. Yeah. Okay, now guys, there is another way which you could have done is an inner text what they refer to it as intelligent grouping, right? I'm not sure if you remember, I'll just do on the side here in a different color. I don't know if you guys actually realized last year that if you have, and I know that these are trinomials, but now I'm talking about binomials, I'll link them together just now. If you have that where you have the same terms, but the one is a plus and the other one is a minus, right? When you multiply them together, you see that this is the opposite of like a difference of two squares, right? If you had x squared minus y squared and you factorize that as a difference of two squares, you would end up with x plus y minus 1. So this is actually like a rule that you can remember, or almost like a shortcut. Okay, that if you have two brackets that you're multiplying together, two binomials, which is part you would have gotten last year, you have the same two terms, but there's a plus in between them in the one bracket and a minus in the other bracket. Then you can just do the first term squared and then the last term squared with a minus in between. Okay, why that will happen is because if you're following this out, you say x times x is x squared. Then you do the alters. X times negative y is negative xy. From here you'll get plus xy. Right? So negative xy plus xy is 0. And then you'll get y times negative y is negative y squared. Okay, now I'm going to show you how we can use this concept to make this calculation slightly different. Okay, and maybe in this case it was quite easy to do multiplication. I don't think it was that bad, okay? But it might get a bit more complicated, then it helps to have a shortcut or to be able to identify a shortcut. What if I rewrite this question in this way? I have a plus b plus 2c, and then a minus b plus 2c, like that. Are these two brackets equal to those two brackets? The first one definitely, hey, I literally just put a bracket around b plus 2c. Okay, the first one I think is quite easy to recognize that all three of these terms are exactly the same. But what I've done to the second bracket now is I've taken out -1 as a common factor in a sense from these two terms, so that I have a minus. Now what is negative b divided by -1? Positive b, right? And what is negative 2c divided by -1? Positive 2c. Is this the same as these three terms, guys? What am I going to do? If I take this -1 and I multiply it into this inner bracket now, -1 times b is negative b, and -1 times 2c is negative 2c. Right? So I've actually that's why they call it an intelligent grouping, because in a sense, I've almost like grouped these two together so that I get that. Do we now notice that this looks similar to this? Right? Where we have a, plus and minus in the same bracket and the same bracket. Right? Just check it out in sense here. So I've basically taken out -1 as a common factor from these two terms so that I have a b plus 2c and then a b plus 2c there. Now how does that help me? When I'm now actually multiplying off. If I want to use this rule, that if you have the same two terms, but a plus in one bracket and a minus in the other one, yes? Yeah. A by A, yeah, which is A squared. Yes, good. So I'm basically applying this as a rule. Right? I'm going to say that again, guys. If you have two brackets, in the two brackets you have two terms. Do you see that by also grouping them together, I have turned three terms into two? You notice that, right? Because here, if it's just written like this, it's 1, 2, 3 terms in that bracket. Now by putting brackets around it, so it's a bit of a manipulation, it's a bit of a trick that we're doing, okay? By putting brackets around the b plus 2c, I've actually turned that into one term, all right? It is a little trick that we're doing, but now we have a plus b plus 2c. So we actually have two terms here now. Then by taking out -1 here and grouping those two together in brackets, I also only now have two terms in that bracket. Okay, technically three, but we've done a bit of a trick. We've grouped them together so that we now have two. So if we're looking at this, how do I get to x squared minus y squared? The first ones, and then the last ones, and then we put a minus in between. Remember, it's the opposite of factorizing a difference of two squares. We can write that as well. Opposite dots. You guys use the abbreviation dots last year? Squares? Okay, if not, you can write out the it's fine. Okay, so now when I have that, when I have two brackets, same terms, there's just a plus in between those first two and a minus in between the second two, then we take first times first. A times A is A squared. We put the minus there, right? Because it's supposed to go to a difference of two squares, so there has to be a minus. Then we take last term times last term. Right? If you were to FOIL this out, which you can also do if you just want to double check, you would say for outers, you would take A times negative this bracket, right? Which is going to be negative A bracket B plus 2C. Then for your inners, you'll say this product, which is positive A B plus 2C. So they will cancel each other out. Yeah, now do you think I can leave it like this with that bracket squared there? No, okay, we have done some multiplication, but it's not fully simplified. So the a squared we're going to leave as it is. Now, do you guys know the shortcut for squaring a binomial? Okay, there's a meaning here behind me. That is the shortcut. There's another one over there. That matters me if you guys find it, please bring it to me. All right, a lot of people think that this is what you need to do. A lot of people think that if you have a bracket squared, you just square the first term and you square the last term, but then that could get that. Okay, so this is the shortcut for squaring a binomial. You can write it down. Can you guys read that thing? Should I rather use a different color? Okay, cool. I'm glad.
First thing, how do you get to AC?
Where are we now? Yeah. Okay. So shortcut for squaring. And guys, you can get by without knowing these shortcuts. Okay, I don't want you to think, oh gosh, now I need to memorize all these things. If I forget them, I'm going to get it wrong. You can just do it the long way around. Okay, you can FOIL out and simplify. That's perfectly fine. All right, but if we're trying to save time and if you remember these, then silence. Okay, so the shortcut for squaring a binomial, if you have a plus b squared, the shortcut is that you will take your first term and square it. A squared, right? For your last term, we're going to square the last term, but you have a middle term. Now, what you do with the stuff in the bracket, in order to get the middle term, is you multiply these two terms together, right? So a times b is ab, but then you have to double it. Okay, so you'll say plus 2 times ab. So whatever those two are, we're going to practice it with this one now. All right, whatever your two terms in your bracket are, you're going to multiply those two terms together. What you get, that product, when you multiply it, you're going to double it, times it by 2. That is then your middle term. All right, and then for the last term, you are going to square the last term. That is in your bracket. And the reason for that, guys, if we were to write this as a plus b times a plus b, right? That is what it means when squaring a bracket, right? Multiplying the bracket by itself. Does that make sense? So now if you were to spoil this off, this is what you would get, because you would say a times a is a squared, a times b is ab, b times a is another ab. Now what is ab plus ab? 2ab. And then b times b is b squared. Yes. No, it works if it's negative as well. So if it is negative, then the only thing, I mean, if there's a minus in between, the only thing that's going to change is that this middle term will be negative. Okay, but it's not going to come up here, but I'm sure it will come up some point today. So if one of your terms is negative here, then when you multiply, say this was a minus b, then you'll say positive a times negative b, right? Is negative ab and double that. Okay, so the same shortcut still applies. All right, so that's another little side note there. But again, guys, if you feel like duplicating this or you are unsure if whatever shortcut you're trying to use is correct, you can do it the old way. There's nothing wrong with that, right? You can write it as 2 brackets and pull it out. That's perfect. Okay, what I'm trying to get to is that we now need to square this binomial. Now, please note that we are supposed to subtract this binomial squared. So the product now, right, when we get these 3 terms, we need to subtract all 3 of them. So how am I going to show that? How am I going to show that I'm subtracting 3 terms? What must I put in? Ready? Yes, I need to put my product here in brackets. Okay, because that's very important, guys. If you don't put your product in brackets, you're going to get it wrong. Okay, let's practice the shortcut now. What is the first term? Squared. B squared. For my middle term, I'm going to multiply these 2 terms together. So what is b times 2c? 2bc. And it's positive, right? Because both of these are positive, okay? Now what is 2bc times 2? 4bc. There you have your middle term. And then the last term squared, 2c squared. 4c squared. Remember, you have to square the 2 and the c. Okay, good. Yes. No, you can't. You have to first do the exponent before you multiply. All right, is that fine, guys? Now this negative 1 that is actually here, right? And the invisible 1 we now need to multiply in. So we have a squared minus b squared minus 4bc minus 4c squared. Okay, now I suppose many of you are thinking that's more steps than up there, right? It is more steps. And it is, I suppose, more complicated, all right? But it might come up that, yeah, maybe you have something that's very complicated and the actual multiplying will be a bit longer. But yeah, it is up to you guys which method you use. All right. But we need to try and start looking for patterns. That's actually the more important thing here. As opposed to this exact method, we need to start looking for patterns, ways in which we can identify patterns, in which we can put them together. Yes.
And so here you're trying to find the common factor.
For these ones. So I don't want to use the term common bracket because then you start thinking of factorizing, but yes, so that I have this scenario. Okay, so not really a common bracket, but more that these two are the same. Okay. All right, let's look at another type of example. We're getting into some fractions here. I do not want you guys to be scared of fractions. All right, I know that, lots of people don't like fractions, but fractions are fun. You're going to work with fractions a lot this year. Even if you weren't doing AP, you would have to get used to working with fractions. Yes. So that is saying that it's just another method of multiplying this together. Instead of multiplying out the long way, we can recognize that this is the opposite of a difference of two squares. So if you have a difference of two squares and you're factorizing, you would get two brackets with the same terms and a plus and a minus. So you can go the other way around as well. If you notice that you have two brackets like that with the same terms and a plus and a minus, you can multiply it out. It becomes a difference of two squares. So that's what you do here. You have the same term, plus minus, so we square the first term, and we multiply the first term, and in the last, and we put a minus. So this is the rule that we apply here. I can explain to you the later, because I think you were not with it. All right, guys, let's look at that one. I want you to try to do that on your own without the use of a calculator, please. We are too reliant on our calculators these days. So let's do this without the use of a calculator. Firstly, if you see mixed number, mixed fraction, what do you do first? Turn it into an improper fraction, right? Please don't work with 1 and 2/3 all the way through. All right, we'll turn into a little bit item. So change that first. Hopefully you can remember how to do that. Okay, and then you're gonna have to FOIL. And then find any like terms in here. That's exactly. Yeah, you kind of already. Guys, remember you can leave your answers with improper fractions, guys. If you're getting an improper fraction in your answer, you don't have to convert that to a mixed number. In fact, if you do convert it and convert it incorrectly, you have to take off a mark. All right, so there's no mark awarded for doing it correctly, but they will take off a mark if you do it incorrectly. So rather save you that time yourself that time and just leave it as an improper fraction. I'll just give you 30 seconds or so to finish off. Yes.
Get. Then.
So the only way to add or subtract fractions is if they have the same. No, so there are other groupings we just haven't done any. So we still have to do like the sum and difference of cubes. That's something new, and then we can use that as well. Okay, but we haven't done that yet. Okay, let's take a look. All right, I have two lines here, two options. Are we fine with our first line where I just converted them to improper fractions? Right, 1 2/3 is 5/3, 2 1/2 is 5/2, and then 1 1/2 is 3/2. Then I FOIL them out. Now guys, depending on how you multiply fractions, you either would have had this or this. Okay. Now, what happens when you multiply the first two? There's nothing that could cancel out. Normally, I do like a cross canceling when I multiply fractions. Okay. In this case, it actually would have saved you some time if you didn't do that, which is what you would have gotten if you got this. All right, so I'll show you now. 5 times 2 is 10, 3 times 3 is 9, x times x is x3. Find the first term. Okay, x is the first term. All right, then we do the outers, or you can do the inners first, guys. It doesn't actually matter. All right, we'll just say outers first. So now you're going to say 5/3x times -3/2y. So I'll just write that on the side here. So 5/3x times -3/2y. Do you agree that you could cancel out those 3's? Right, which is what I did at first. Then you would get -5/2xy. But if you didn't cancel them out, guys, if you just said what's 5 times, well, negative, obviously, then what's 5 times 3, 15, and 3 times 2 is 6, xy. That's also fine. In this case, it actually would have been better, right? If you then do the inners, you have 5/2y times 2/3x. The 2's again will cancel out, right? So you would be left with 5/3xy. Or if you didn't cancel them out, you would say 5 times 2 is 10, and 2 times 3 is 6xy. Now guys, you can see that I've underlined these two terms because they are like terms, because they both have xy as their variable, right? In this case, if you didn't cancel them out, which is what I did at first, you now would have to change those denominators. You would have to find the LCD before you could add them together, right? So you would have to do another step. What is the LCD of 2 and 3? 6. All right, so you would then have to say, okay, to turn 2 into 6, I must times the top and the bottom by 3, which will give you that. To turn 3 into 6, I must times the top and the bottom by 2, which will give you that. All right. But like I said, if you didn't do this calculation that I am just used to always doing when I multiply fractions, then you would have already had the same denominators. Okay, so then from here you would be able to just add those together from the start. Right, but it's fine. If that was your first step and then you did equals that and then you got to that answer, fine. All right. Is this answer correct? Did anyone ask it? Yes. Yeah, we'll check that. Okay, guys, we are out of time. I'm just going to give you like 3 of these to practice. So just write this down first, please. Or you can take a picture also if you want. But I'm just write them down. So homework number 1. Let me know if there's anything there that you can't read. You just want to show what I've written.
Now, we practice the same thing.
Practicing the stuff is good. Okay, that is your homework for Monday. Right, and then you can back up and go. Yes. This one here, 1/5. Have a lovely weekend, guys. I will see you on Monday.